Hello friends, welcome to online school. And then in this section, let's talk about differentiation of logarithmic functions. And then so what are logarithmic functions? Logarithmic functions is a functions of log base e. And then so let's have a look at an example here. You can have y equal to log base e of x. And then so this is the same as y equal to ln x. And so functions of this format here, they are the ones we call logarithmic functions. And so let me write the general form. We shall have y equal to log base e of fx, like that. And then so this is the same as y equal to ln of fx. And then so how do you differentiate such functions? And then so let's begin from here using the rules of logarithm. We know that a base to power this to this, a base to power of its logarithm, it is equal to, we shall have a base here which is e to power its logarithm exponent of y will equal to this fx here. And then so let's try to differentiate this so as to come up with a general formula for differentiating logarithmic functions. So I will introduce d by dx on both sides. We shall have d by dx of exponent y being equal to derivative of this fx right there. And then so from that, remember we've looked at differentiation of exponential functions, and then this is exponent y, so we shall have, when you differentiate it, we shall remain with exponent y. But then remember, since y is a function in terms of x, so we shall use chain rule here, and then when you differentiate it, we shall have exponent y times dy dx, like that. And then this side we shall have d by dx of fx, like that. And so on simplifying this one here, we shall have divide through by exponent y to get dy dx being equal to, then so we know that d by dx of fx, this is the first derivative. We hope we looked at this from the section of the derivatives. So this is the same as f prime of x over exponent of y. And then so this one here, remember exponent of y, from this equation here we have that e to power y, it is the same as fx, so we shall have here that f prime of x over f of x. So from this you can draw that the derivative of logarithmic functions, it will be the derivative of a given function divided by the very function. And then so this is the same as our y, which was ln x, so we can have the derivative of ln x, of ln of any given function fx, like that. It is equal to the derivative of that function over the very function fx. And then so when we get back here, remember we had that y equal to ln x, which is the same as y equal to log base e of x. So whenever you differentiate ln of a given function, you will get the derivative divided by the derivative of that function over the very function. And then so let's have a look at some examples here. We are just going to apply that formula, the one we have derived. So assuming we have our function y equal to, let's begin with y equal to ln x. How do you differentiate that? We shall come here and we say that dy dx, it is going to be, now our fx here, in this case here, our fx, it is an x, so we shall have, and then the f prime of x, which is the first derivative of x, is 1. So the answer for this, it will be 1 over x, and then that is the derivative of the function y equal to ln x. So we can have a look at another example. Assume we having our function y equal to 1 plus assume we have our function y equal to ln of 1 plus 2x. And then so here in this case we have our fx being equal to 1 plus 2x, and then we shall have our f prime of x being equal to, this will be a 2 because this will give us a 0, and then this one here, it will give us a 2. So the dy dx of that is going to be 2 divided by 1 plus 2x, alright, like that. So let's have a look at another function still, assuming you have y equal to In this case, so we have y equal to ln of 1 minus 3x squared, right, like that. So in this case, you have our fx being equal to 1 minus 3x squared, and then f prime of x of that function there, it is remember, this will give us a 0. This one here, it will give us a 0, and then this one here, you shall have 2 times negative 3 to give us negative 6x. Negative 6x. When you differentiate this explicitly, right, from we looked at it from the first section, we shall have negative 6x like that. And then so the d by dx of our y, you can even write it in this format, d by dx of ln of 1 minus 3x squared, which is our y, dy dx, this is the same as dy dx. It is equal to our f prime of x, which is negative 6x, divided by 1 minus 3x squared. So these are derivative function of this function here, of this function y, which is there. And then so from that, this logarithmic function, it is essential in let me try to use an example to explain this, because you may find that you're given an example of such a function that differentiate y equal to ln of 2 power x like that. So now how do you differentiate this? Oh no, let's use this, it will come out clearer. So differentiate y equal to 2 to power x like that. And then so how do you differentiate such a given function there? So we shall introduce ln on both sides, and then we say that ln y, equal to x ln 2, right, like that. And then when you differentiate this, we shall have 1 over y dy dx being equal to this ln 2 is a constant, ln 2 dx like that. So now, since this is a function y in terms of x, that's why we are using chain rule here. And then you know that when you differentiate ln of any given function, it is 1 which is dy dx over this here, and then it is the same as 1 over y dy dx like that. And so we shall have finally that dy dx will equal to ln 2 over y, which is the same as ln 2 over 2 to power x like that. And then so this is our derivative function of this given function here. So from that, we can also have another example that differentiate y equal to ln of 6x squared. We can also have y equal to x to power x, is that one there. So it is the same as this, you use the same technique. And then differentiate also y equal to ln of 1 minus 2x to power 4. We can also have y being equal to exponent of x 1 minus x squared like that. So and then this one here, you can even apply ln, and then it will become easier to differentiate. Thank you for watching. Subscribe and share the video.